As MIPI C-PHY and D-PHY links get deployed in more bandwidth-intensive applications, they require more advanced test systems for the purposes of characterization, design validation, and production testing. Hitting the data rates that are mandated in the C-PHY version 2.0 and D-PHY version 3.0 specifications require very high bandwidth, sophisticated signaling technologies, and highly complex system level and protocol features. When it comes to testing such links, traditional solutions are often insufficient. Oscilloscope-based solutions may not have a sufficient number of channels to capture complete protocol traces from a MIPI C-PHY or D-PHY link, and testing complete mobile systems with cameras and displays via CSI and DSI protocols present enormous and unique challenges of their own. Introspect technology is proud to be an industry leader in innovative solutions for C-PHY and D-PHY test applications. In today's presentation, we'll introduce the latest innovation in the Introspect family of products, the SV5C-DPRXCPRX combo MIPI D-PHY and C-PHY analyzer. And then, with a focus on C-PHY display technology, we'll demonstrate an important application, probing and analyzing of live DSI traffic. And we'll perform this live on a commercial phone, demonstrating just how easy it is to use Introspect's instruments, software, and probe technology, even for the most challenging C-PHY and DSI applications. Introspect has pioneered MIPI testing with the SV3C product line, and we're now proud to introduce our new Introspect SV5C-DPRXCPRX combo MIPI analyzer. In a single handheld instrument, this analyzer offers double the bandwidth of the Introspect SV3C solution, increases the memory depth, and provides an even expanded analysis capability. Featuring a completely new analog front end and an updated software environment, the SV5C analyzer can receive video frames at the highest MIPI specified data rates, can provide incredibly deep insights into physical layer or protocol layer events. Moreover, it has true combo input pins with the same set of pins either acting as a 4-lane D-PHY port or a 4-trio C-PHY port. LPHS switching is handled automatically. There's no need for a termination board or other external equipment. The SV5C analyzer provides analog waveform capture capability for both single-ended LP and differential HS signals, and it can do so on live CSI2 or DSI2 traffic. Simply transmit a video frame and create an analog capture component in Introspect's award-winning Introspect ESP software. Then, press Run. Captured waveforms can be observed using the software viewing tools, and measurements such as rise and fall time, voltage levels for D-PHY, and strong and weak amplitude voltage levels for C-PHY can all be made in software. Additionally, the analyzer can capture both D-PHY and C-PHY eye diagrams, with triggered eye methodology used for C-PHY. The SV5C MIPI D-PHY and C-PHY analyzer provides complete protocol analysis for both CSI2 and DSI2 data, and the Introspect ESP software provides intuitive viewing tools presenting captured data in terms of frames, packets, LP states, or HS bursts. Note that hyperlinks make for easy navigation between the tabs. The top of the viewer provides a capture summary. Then, starting from the Frame tab, the top half of the tab provides a table view, with each line representing one complete frame from CSI2 or DSI2 captured data. The bottom of the tab displays the reconstructed images. The CSI2 or DSI2 packet tab displays merged lane packets. The top of the tab provides a table view with header decoding for easy high-level viewing. Packets can be searched by type, and all packet errors are highlighted and indexed for search. Between easy-to-use data capture software and easy-to-navigate hyperlinked viewers, Introspect ESP software provides all tools required for deep CSI2 and DSI2 protocol analysis. We'll now demonstrate how useful these features can be in the second half of this presentation when we'll make analog captures from live DSI packets on a commercial cell phone. Smartphone and mobile influenced display technology is evolving rapidly to cover the different use models associated with generating and consuming content. This has led to an ever-increasing demand for display resolutions, refresh rates, compression technologies, and gesture control technologies. One of the advantages of C-PHY technology is that it enables higher resolutions while keeping link data rates relatively low, and this helps avoid electromagnetic interference with the modem and other radio components on the phone. C-PHY signaling also has beneficial spectral properties that help it coexist more easily with 5G components on the same hardware. We'll now show a demonstration of monitoring live C-PHY, DSI traffic on a smartphone using Introspect new PV2 probes, the SV5C-DPRXCPRX combo analyzer, and Introspect software tools. In the test setup as shown, the high-speed bus connecting the phone's main processor and display panel has laid out on a flex PCB with probing points available for direct attachment. A small interposer has been created to sit under the test points of interest, and Introspect PV2 soldered down probe tips are attached to the interposer as shown. Introspect's PV2 probes, as shown here, are capable of capturing data on a bus at up to 8 gigabits per second. The PV2 probes are universal. That is, they may be attached via SMA cables to display on any piece of test equipment such as a scope, and in this case, they're connected directly to the SV5C analyzer as shown in the diagram on the left. From within Introspect ESP software, a test program to capture live traffic can be created with just 6 pre-built software components and just 2 or 3 lines of Python code, as shown here. Start the execution simply by pressing the Run button at the bottom of the screen. We'll start by looking at an analog capture of live DSI packets. Double-click the result folder icon to view the captured analog data. You can view all 3 trios, choose individual wires, and observe entire packets. The following is data from a real phone display as shown, monitored with PV2 probes. Now, let's move to DSI capture and protocol analysis. The viewer automatically generates a video timing diagram for easy visualization of the frame parameters. The viewer for the frame tab displays the received images from the phone, table view statistics on the top, and reconstructed images on the bottom. Note that these 10 frames were captured error-free. If there are errors in a capture stream, they can be searched directly in the packet viewer tools. Searches can also be performed on specific DSI data. The SV5C can be used for deep protocol analysis. For instance, the SV5C can be used to capture and observe all DCS commands used in a panel startup sequence. Note that the column on the right provides details on the DCS command that it detects. At the end of the sequence, the panel exits sleep mode and turns the display as shown here. There's extensive DSI support provided by the analyzer. Display command sets are supported, and both DSC and VDCM decompression are available as well. PPS tables can be added in a single component in Introspect software. The following shows an example of compressed frames captured from the phone, first without decompression applied, and then a captured frame, this time captured with the desired decompression applied. A total of 8 GB of memory is available on the SV5C analyzer for received packet data. Whether your application is at a chip level or at a system level as demonstrated here, Introspect instruments and ESP software allow you to develop and test with clarity and confidence. For more information on these or any other Introspect products, please contact Introspect Technology.